we shall move further with time complexities. So see, like every code segment you write has some time associated with it, time complexity. So we generally denote the time complexity with big O notation. Okay, so some variable is here or some constant is here, let's say x, which denotes that around this number of iterations or around this complexity the code works. Let's say your code is something like this. Int a equals to, let's say, 5 and int b equals to a plus 5. So these kind of statements work in of one. We take these as a symbol, like these are of one statements. So these are our unit statements. Let's say for calculating meter, you take a unit as like 1 centimeter and you calculate 100 centimeters as 1 meter. So these are our units. So this is an of one thing. Okay. So if you, let's say, write something, let's say now I take some for loop int I equals to 0, I less than, let's say, I to let int a equals to, let's say, 5 and int b equals to a plus 5. Even let me just take I here. So now we are doing the same thing 100 times, that same unit thing like 100 times. So the total complexity of this code will be, let's say, of 100. So now if I change this 100 with some n given by, like, this is of some variable given by the user or given as an input in the question. So this thing changes to something like this. So now this and let's say we consider that in this loop some unit statements are written that don't need any computation or require high computation. So this is a code of, like, this for loop is of the time complexity big O n. Okay, so this is the time complexity, or let's say this much iterations will be required to run the program. So now we'll understand that let's say now if there is some nested loop to your code. So let's say there is this thing and there is this thing for n, again j equals to 0 to j less than n, say j plus plus, and let's say there is some statements here which we treat as of one. Okay, so now the total complexity, so how many iterations will be running during the running of these two for loops?
N square.
Yes.
N square.
Yeah, n square. So for every I, there will be n times this loop. This statement will be run for every I, and there are another n times this will run. So total of n square. So the time complexity of this is of n square. Okay. So that's how you calculate some time complexity of some code, but how many time a thing is running. So let's say let's take some another example. Let me just change. Where is the? So let's me take that from j equals 0 to j less than I compute. Now what will be the time complexity of this code? For int I to 0, I less than n
plus 1,
and for int j 0, in fact j less than I, j plus plus. Okay, so how we will be calculating time complexity every time is you can either like after some practice you will be doing it in your mind only, but mathematically you should always try let's say for first I equals to 0, how many times will this loop run? For I equals to 0, how many times will the inner loop run? J equals to 0, j less than I. For
One
I
time, one
equals to
time.
0.
First time it will run one time, then two, and then three, and like that. It will be.
So it will 1 plus 2, 1 plus 3, let's say up to n times it will. Like let's say something is like that. Even if you take 0 plus 1 plus 2, that doesn't differ anything. This loop won't be running, but we still be checking one condition. So let's take 1 plus 2 plus 3. So what is this summation? We know that it is n into n plus 1 by 2.
Sir, I
So
have
we
one
can
doubt here.
say that it is like what?
Sir, last term will be n or it will be n minus 1?
So let's see, you can let me just explain one more thing. I just skipped that. See, of n is equivalent to, if you take like of 2 times n, it doesn't takes any difference. Even if it's equal to like 2 into n plus, you can say like 10 or something. Like even if you do 100, it won't make much difference if n is larger than 100. So see, this of n, big of n, that in terms of time complexity, even if like let's say this loop, I run it 2 times in my code. So even if its complexity is of 2 times big of n, we treat it as big of n. Okay, even if you add something, even if you subtract something like which is smaller than compared to this value n, let's say n is of the order 10 to the power 5, then these things such as 2 times n or 2 times n plus 2 doesn't make much difference to our code. So its complexity is still of n. So while computing the complexity, even if you take any iteration as n, or even if you want to take any iterations as n minus 1, so it doesn't make any difference.
Sir, and if we have both n square and n, then the complexity will be n square.
Yes, if let's say, yeah, you take the bigger thing. Let's say if your total time of running the loop, your code is something like this, so you just take it as of n square. The bigger thing, like this is definitely n square is bigger than n, so we take this thing only because that is much smaller than this thing, so it doesn't make any impact. Even if this, like if it's n square by 2, let's say, or by 3, or by something like 10, so even it remains big O n square. Okay, so what we see is that if we take for loop from I0 to I less than n and j equals 0 to j less than I, so we see that for the I equals 0, this loop is run for 1 or let's say 0 times, then 2 plus 3 up to so on. So total number of iterations will be, summation of this will be n into n plus 1 by 2. So this is like, you can say n square plus n by 2. So we can just ignore other values and say this is of big O n square. Is it clear?
Yes, sir.
So everyone, is it clear? Like there are other 30 students as well.
Sir, but why do you make it like that?
Yes. Sorry, I couldn't get your question. Yes.
Sir, like how can we take both, like when we multiply by 2, I can't explain that. How is this n and 2 and same, sir? Like,
Okay, in like in doing time complexity, this thing is like same because let's say like we are calculating, let's say, iteration. So you write this for loop 2 times in your code. Okay, so this big O notation is like in what proportionality will your code run. So you have done like let's say something is proportional to like alpha or like beta something. Okay, so even if something is proportional to, let's say, x or proportional to 2 times x, so this thing generally, like, it will imply this thing as well, isn't it? If something is proportional, this big O is something like proportionality thing. So if something is proportional to 2 times x, we can say if x is quite bigger than 2, something 2, or let's say we can change this rule so that like let's say 10 or 20 in case of 2. So we can say it is proportional to x. Okay, this doesn't make much difference, 2 times x. On edge cases it may, but we will discuss about that. Okay.
Okay.
So now this is how you calculate some time complexity. So even there may be at times there may be code such as when you will be taking square root. Let's say you will be doing some for loop from I equals 0, I less than some square root of some number, let's say x, and then I plus plus, and if you run this loop, so the total time complexity will be of order of square root x. Okay, square root x, because square root times number, square times the for loop is executed if there are unit statements in this code in under the form. So yeah, so generally in programming question you will have a specific time limit. As we discussed last time, you would remember that I opened one question of factorial and it was written 1 second was the time limit, or sometimes there will be time limit. So what is this time limit is that in general you are allowed an equivalent of big O 10 to the power 8 iteration. Okay, so if your code is executed within this time complexity, then it will be accepted. There won't be any time limit exceeded thing. But if you take more iterations than that, then it certainly it will be a problem. Let's see that there is some let's say given an array, let's say n, and its size is less than equal to 10 to the power 5 is given. So at max the size can be 10 to the power 5, and you write a code. Let's say you write a code with a time complexity of big of n square, and your friend write a code that does the same thing like you, but obviously he has done something extra and it does this of big of n like this. Okay, so of n square, this results into like 10 to the power 10 iterations, while your friend code will result into 10 to the power 5 iterations. So being the time limit 1 second or 2 seconds, like this thing is accepted 10 to the power 8 less than anything less than equals 10 to the power 8 will be accepted. So this code will be accepted, while this will get a TLE, which is time limit exceeded. So see, most of the problem in competitive programming, you will see you can pass if there is no constraint on the time. You will be able to pass if there is no constraint on time, because you can then do anything. Like you may write like hundreds of for loops, and your complexity may be something like n to the power n even. Like if there is no time constraint bound, then you may pass a solution with n to the power n like time complexity. But since in this real world we do have some constraint on the resources, so resources on time, resources on memory. So this is the general constraint given to you, so you have to pass in this constraint only. So that's why there are some optimization techniques, there are some more and more algorithm designed to solve the difficult problems, so that there isn't any issue of time complexity. So that was for the time, and again same thing applies for the memory as well. Let's say you cannot generate an array on the memory. Most of the time, like let's say memory can also be related in terms of your time complexity as well. Let's say if you wanna store an array of, let's say, 10 to the power something like 10, so this isn't valid. You cannot use this much memory in your code anytime. Okay, so
Sir,
that
2
is
to the power
also like
32.
memory constraint.
Sir,
So memory yes.
sir, 2 to the power 32 minus 1 is the maximum, and after that anything we cannot store. So,
No, no. See, this is the memory limit. See, even if you are confusing memory limit with the integer int, see, let's say int AR2. Okay, so there are two elements, and let's say even if this is long int, I can store AR0 as something like 2 to the power 3 minus 1, or let's say, or 10 to the power 18. Okay, so you can store a number as much great as you want until it satisfy your data type range, but you cannot use a memory like I have used 2 cells or 2 times 4 bytes, so you cannot use a memory greater than 10 to the power 8 of 10 to the power 8. Like you cannot use an array of like 10 to the power 10. So these much indexes are not possible in an array. You cannot create this array. You will get a runtime error. Is the difference clear? You can store a large number, but you cannot create indexes much greater than this 10 to the power 8. Is this clear?
sir, then what is the maximum limit? Like,
10 to the power 8, or you should take like 10 to the power 7. And let me just show you that even one second. See, in your int main, you should not declare, you cannot actually declare something like let me say int x equals to 1e7, and you declare like 1e7 is 10 to the power 7. So in main, in some function, you cannot take an array as large as this. You should restrict yourself to 10 to the power 5. On global, let's say outside, you know that outside your function, whatever you write is your global thing. Like there are global variables, and there will be maybe global arrays as well. So if you write something like int y equals to 1e7 and take int, let's say bry, so this thing is valid here. But if you take 1e7 here and try to write like arx here, so this thing isn't valid. Yeah. So that's out of bound thing. So there is a limit on time, there's a limit on memory as well. So obviously you can like correlate memory with your time. See, if there are 10 to the power 10 indexes, then definitely you cannot even traverse all the indexes to store something, isn't it? Like how do you even take input in an array? Let's say n is the size of the array, and then you scan something. Okay, so if already there is a limit on how much time this loop can run, which is 10 to the power 8, so definitely you cannot take that much memory already. Okay, so these are the two constraints on time and memory. So is time complexity clear? How we calculate time complexity of some code, and how and why is there some time limit, and how much iterations are possible to actually accept your code within that time limit. Are we clear till this point? Are we clear?
yes, sir.
Everyone, any question till now? Any question? Okay, so Prince, next functions करा दे. तू अपनी स्क्रीन शेयर कर ले, ज़्यादा सही रहेगा. हाँ, ये बोर्ड शेयर है ना? हाँ, ठीक, कर ले. से स्क्रीन विजिबल है? हाँ हाँ. So next we will be seeing function. So what is a function, right? So inside our code, what happens? So when we are writing something, there may be some task which we need to compute again and again, right? There may be some task. Suppose what we want to find the minimum from an array, minimum or maximum from an array, and we don't know we don't know the mean and the man function. We don't know the inbuilt mean and the man function. So what? So how do we do it? Font size कैसे increase कर सकते? क्या? Font size.
फॉन्ट साइज वो टेक्स्ट के आगे 16 बना है ना, इंक्रीज कर ले एक से ये छोटा. हाँ अब ठीक.
Suppose we want to compute the minimum of an array. So what we will do, like int I equals Right. This is the general thing what we do when we compute the minimum of an array. But what we are using here, this function, this mean function, and that is already inbuilt, right? That is already inbuilt, and that is given by our compiler. But if we don't have this, so what we need to do here, we will be doing something like if our already what answer we have computed is greater than of I, so you can see like this as it is a small code, it won't affect much, but if it is a large part, right, if this subtask is large, our code will be larger, but that will not be significant. So if we have some task and we want to do it again and again, so we make some separate function for that, and that function will be doing its task. And suppose like consider another example. We want to compute this value. Alright. We want to compute this value, a to the power b to the power c to the power d. So how can we do this? One way of doing it can be like first we will compute a to the power b, then whatever will be the answer we will compute it to the power c, and whatever comes the answer we will compute the power d, right? If we only had a to the power b, then what we can do, like we will run a loop. A to the power is what? A to the power is nothing but it is equal to a into a b times, right? So if we multiply, let's say this is our answer, right? And if we do this way, like, so is this code fine for computing a to the power b? Like this part. Is this part fine for computing a to the power b? Can you
One
not check?
second, sir. 1 second, sir.
So
Sir,
a to the
answer
power
into B or
is what?
answer into A? Below answer equal to answer into B or answer into A? Last line.
A to the power b is what? It is the a into a b times, right? So what we are doing, like we have run a loop, right? It will run how many times? B times, starting from 1 and up to b, and each time we are multiplying inside answer into 1. This is nothing but multiplying a b times, right? Is it clear?
Sir, it's a little confusing. Like, I will run B
Okay, let me
times.
give you an example.
See.
answer is 1, our answer equal to 1. And when it will go inside the loop, it will simply multiply a, right? It will run only one time, it will multiply a, and our answer will be 1 into a, right? And now again think like if b was 2, right? So for the second iteration, our answer is already a, right? And we will multiply answer into a. Answer was already a and we are multiplying it by a, which means this will be a square. Is it clear?
Yes, sir. Sir, for all values of b, a is only getting multiplied. So even if b increases, a is getting multiplied every time.
Yeah, a to the power b is exactly that thing, right? If we have to compute a to the power b, then that will be a into a b times, right? 4 to the power 4. What it is? It is equal to 4 into
पावर का साइन 4 to the power 3 कर ले
okay. 4 to the power 3. What it is? It is equal to 4 into 4 into 4, 3 times, right? We are multiplying 4 3 times. Similarly, if we have to compute a to the power b, what will we do? We will multiply a b times, right? Is this clear, right? This part of computing a to the power b.
Naveen कुठे आहे? Naveen वापर.
I can say yes or no. Fine. So what was our aim? So our aim was to compute this value, a to the power b, whatever comes to the power c and whatever comes to the power d. Right? So if we don't know anything, what we will do? Like we will do this part 4 times. This is for multiplying b, and then again multiply d times. Right?
see every time it's acting like 3 loops. First of all, it is power b, then we'll get some answer, we'll again repeat c times, then you will repeat line again. Okay, so that will be some repetition of the code, and yeah, writing the same part of the code like multiple times is like an extra thing, and you should always avoid that. So what we can do here is write a function that takes some two numbers, let's say a and b, and just return us a to the power b. Then we can again call that function for give like
We'll call that function again and again, and that will compute our result, this result.
first parameter will be your answer till now, and the second parameter will be the next power you wanna compute. So function लिखते हैं परी, मतलब same चीज हम function में return करा देंगे. So the function is nothing but like a code which accepts some, let's say, inputs as a parameter, and then there is some data type which it will return. Like see here, it is written int multiply whatsoever. So it takes two parameters, int a and int b. So that int before that multiply word denotes the return type, what we shall be returning through this function. That may be void, that may be boolean, a character, a string, even a vector. It can be nothing. It can be anything. So here we are returning an integer. So we take answer as 1 and just compute this thing, and we can return answer from here after the for loop. So
Right. This function will always compute a to the power b. This function will compute a to the power b. So whatever the first parameter, so see, this is a simple function, right? This is the name of the function, multiply, right? And inside bracket, inside this parenthesis, we pass the parameters to the functions, and if there are multiple parameters, then we separate it by comma. Like int a is the first parameter and b is the second parameter, and before its name we write its return type. So what the function is going to return? In this case, the function is going to return an integer variable and that will be the answer to a to the power b. Alright, so what was our aim? It was to compute.
So like from main function, you can just call three times. First, take some answer, initialize answer as one. This whole thing is computing in your main function. So we take some variable.
Let's say this is int a. Right, and we say this will be our answer, and every time
We just
compute.
made our answer to the return value of the function. So answer equals to like multiply
Sorry.
here b. Next will be answer to the power c, and then again answer equals to multiply answer to the power d. So as we see, by writing a function, it helps us to save our time in writing code as well, and also the code looks somewhat clean to our previous code.
So we can see if we have done the previous method, like if we compute this a to the power b, then whatever comes the answer will compute to the power c, then the code will grow, and that will be only the wastage, right? We can make our code efficient by this way, by making function. This is the function, and that is for doing a specific task. And here our task is to compute a to the power b. We pass a, we pass b, and the function do some work to compute the answer, and then it returns the answer, a to the power b. Is this? Is it clear? How did we solve it?
Sir,
Yes, sir, it's clear.
multiply integer is a inbuilt function, sir.
No, it is not an inbuilt function. We have written it. Multiply, we have written it. It is taking two parameters, a and it will return a to the power b. It will multiply a b times.
See, writing function is just a thing to like remove your repeated code, and even your code looks clean. Like if there is a one time you let's say even if there is only you need this loop 2 times only, but this kind of thing looks clean in your code that it actually helps you to understand code even if you read after some time, or even if someone else read your code. Like it makes some sense, like there is some function that is calculating a to the power b and you are calling it 2 times, so that makes some sense that how you are getting your answer. So this is, and the motive was to introduce you to functions. Like there may be some, like let's say there is int, there may be some, can be some strings, can be some character, can be a boolean, or even this may be void. So like you don't want to return anything from this function, you just want to do something. So there are functions like that accepts parameters and return something. Okay.
So basically, I'm explaining it again. So here it will be the return type, and then we have function name, and then we have some data type, and then its name. Similarly, we can have multiple parameters, and we will separate it by comma. And inside this block, we write down the code, whatever we want to do with the function, and finally we will have the return value here. If it is void, then we don't need to return anything. We can either skip this part, return, or we can just simply write return. If it was void, if the return type is void, which means that function is not going to return anything, right? If return type is sometimes maybe like we want to print something, right? And we call that function. Suppose we want to print an array. We call that function, and inside this we will print using suppose using this type of for loop. We printed the array, and we simply want to terminate the function. So we will write return. This function will be terminated.
Sir, I didn't understand this line, like this last line which you said.
Which one? Void.
Sir, in void, will we get the answer or will we not get anything, like as the output?
See, you may like do some cout here, or you wanna like change some variables, global variables here, but the return type is nothing. Like you are returning nothing, null from here, so you cannot store anything. Like it's returning nothing from this function. You just call this function. Let's say the function name is multiply only by multiply. So let me one second. You just type your multiply this whole function name, pass the parameter, they does their work. Maybe there may be cout statements here or maybe anything, but you just call these function from here only. You don't store their output, like you cannot get their output since you have created their return data type as void. That just like a code segment that you just didn't want to write in your main function. You just created some another function for that. That's just this thing. Now is it clear?
Sir, so we'll not get anything as output when we use this. Like we will have to do cout to get the answer.
No.
Then
See, it depends upon how you wanna like use that function. As I talked about global variables, so you know, like if you have a global variable something, some global variable, so you can change its value anywhere in any function. You can use that in any function. Okay, so if you have your, let's say, global value, global variable, let's say int y equals to 1. So you make this function, let's say void some function, and you don't take any parameter as well. So you just change y to y equals to y plus 1. Okay, and just nothing. And maybe you write return statement or not, like return like nothing, or you just don't even write for the void thing. So the number of time you'll call it, y's value will be incremented, and after that you can print in your main statement that how many times was function called. Let's say like let me just share my screen. Prince cancel करें. So see, maybe let's say you take some global variable here as one, and you make some void function that does this thing. Okay, so in main function, let's say for some time being you have some code here. Okay, so inside many for loops you might be like wanna how much is this some statement is run. Let's say inside some nested loops you want to detect some how many times the statement is run. So just you can add when that statement is is running, you can just type this like function and just call it. Okay, at the end of the code, what now you can do is you can just cout y and l. So that will actually help you see that how many times was this particular statement was run, because every time the statement was run, it must have run our function as well. So like this kind of things you can do, or even you can do like we haven't discussed pointers right now, but you will be learning about pointers in your ITP class. So let's say if you have an array as an input, okay, so if you change something ar0 equals to let's say 10, so and just do nothing, let's just call this function, then, and let's say you have an integer array here of let's say 10 size, so that actually will be changing your array value at index 0. When you return out of the function, if you try printing AR0 whatsoever was it earlier, now it will be 10. But let's say you have an integer a as 0 here and you pass AR as well as a here, and then integer a is here, and you also want to do something like a is -1, but if you print, let's say
Sir, now it is a
0,
little fast,
a,
sir. Sir,
a and f. This is data row.
sir, voice is breaking.
I'm just saying when they say array as a main as well value in the function and everything, but changing some changing value in your of value a1, but as you return the a this is
Sir, voice is breaking, sir.
A equal to minus, but ఎట్లా got A equal to
see this is the pointer. So we in main